Hello everyone, welcome back to Study Room. I'm Megakshi Rana, your mathematics teacher, and today we are going to begin our chapter number 7, that is cubes and cube roots. So we have already discussed about the squares, their square roots in the previous chapter, and now we will begin our discussion related to cubes and cube roots. We first of all see what are cubes, what are cube roots, the methods to find them, and we will do some examples also. So first of all, we are given this Hardy-Ramanujan number. Now, what is this Hardy-Ramanujan number and what is so special about this number? See, this number 1729 is known as Hardy-Ramanujan number. This is the scientist after which this number has been named. He was the one to discover this because, now what is the speciality about it? It is the smallest number that can be expressed as a sum of two cubes in two different ways. So it is the smallest such number, that can be expressed as a sum of two cubes in two different ways. Let's see how. So first of all, we have this number 1729. Now this number 1729 can be expressed as 12 cube plus 1 cube, or we can even write this number as a sum of 10 cube and 9 cube. See, if you solve the 12 cube and you add 1 cube to it, you will get this number 1729. Or even if you do 10 cube and then add to it the cube of 9, you will again get the same number, that is 1729. This is why this number is special and this number is known as Hardy-Ramanujan number. Now we begin with the discussion related to cubes. We all know that cube is actually a solid figure that has all the sides equal. Now consider this cube of side 1 centimeter. This is a bigger cube. Now in order to make this cube that is of side 2 centimeter, you will require how many such cubes? You will require 8 such cubes to make this cube. From this cube to this cube, you will require 8 such cubes to make this bigger cube of side 2 centimeter. Similarly, in order to make this cube using these cubes, you will require how many? You will require 27 such cubes to make this cube that has a side 3 centimeter. You will require how many such cubes of side 1 centimeter? You will require 27 such cubes. Now, perfect cubes are cube numbers. We have already read about perfect squares. Now, what are these perfect cubes or cube numbers? Perfect cubes or cube numbers are the numbers that are obtained when a number is multiplied by itself 3 times. So when we multiply a number with itself how many times? 3 times, then the number that we get is known as a cube number or a perfect cube. Let's see some examples like 1. 1 is a perfect cube because if you multiply 1 with itself 3 times, that is 1 cube, you get 1. 8 is a perfect cube because 2 cube gives you 8. 27 is a perfect cube because 3 cube gives you 27. That is how you see what are cube numbers or perfect cubes. Let's complete this table. We are given this number and we have to write its cube. So 1's cube is 1, 2's cube is 8, 3's cube is 27. Now in order to find the cube of 4, you will multiply 4 with itself 3 times. That is, you will do this. Now 4 4s are 16, 16 4s are 64. So the cube of 4 is 64. Now what is the cube of 5? In order to find the cube of 5, you will do 5 into 5 into 5. 5 5s are 25 and again you can do it in the rough work. 25 into 5 you get 125. So the cube of 5 is 125. Similarly, multiply 6 3 times in order to get the cube of 6. Do it yourself. Then similarly with 7, 8, 9 and 10. This is how 10's cube is going to be 1000. Very easy. So this is how you find the cube of the number that is given to you. Next we are given some cubes of these numbers from 11 to 20. Let's see what are these. So the cube of 11 is 1331. Cube of 12, 1728. Cube of 13, 2197. 14, 2744. 15, 3379 and similarly so on. Cube of 20, 8000. One thing that you can see from here and even from the previous table is that if the number is odd, what is its cube? Is it even or odd? It's again odd. So the number that if the number is odd, its cube will be odd. If the number is even, its cube will be even. You can see any number, odd, odd, even, odd, odd, even from the previous example, previous table, let's see, odd cube is odd, even cube is even, odd, and so on. So we can conclude that if the number is odd, its cube will be odd. If the number is even, its cube will be even. Now, unit digit of cube numbers. So let's observe this following relation. What is given to us? If the unit digit of a number is 0, the unit digit of its cube will be 0. If the unit digit of a number is 1, the unit digit of its cube will be 1. If the unit digit of a number is 2, what will be the unit digit of its cube? It will be 8. Because you are doing the cube of the unit digit of the number. When you do, just in order to find the unit digit of the cube, you can just simply find the unit digit, the cube of the unit digit of the number. Because 4 cube was 64, so the unit at the digit at the unit place is 4. That is how you find. 5 was 125, cube was 125, the digit at the unit place is 5. That's how you find it. Try these questions, you will get more clear about how to find the digit at ones place. Now find the ones digit of the cube of each of the following numbers. What is the first number given to us? The number is 3331. So in order to find the ones digit of its cube, you just have to find the cube of this number, that is 1. So 1's cube is 1, therefore the answer will be 1. That is the unit digit for this number's cube will be 1. Similarly for 8888, you can even remember this table. 8's cube, if the unit digit of a number is 8, its unit digit of its cube will be 2. You can write here 2, the answer is 2. Either you can remember the previous table or you can just find the cube of the last digit, that is 9. So 9 into 9 into 9, that is 9 9s are 81, 81 into 9 again, 9 1s are 9, 9 8s are 72, so it is 9. Therefore, it will be 9. The answer will be 9. You can see from here. Please do the other parts yourself in order to get more practice and in order to get more clear about this. You can just see from this table and then remember it, or just apply this method. What's next? So this was all about this video, lecture number 1. In the next video, we are going to do some interesting patterns. We will see some interesting patterns related to these cubes and cube roots. I'll meet you in the next video. Till then, bye-bye.